Hello everyone, today's video is the humble 555 timer. So today we're gonna be making a 555 timer, a stable mode. So I have here this little IC. It's really old IC from the 70s. The tools you're gonna need for today is IC socket and the IC, two 10K potentiometers, two 1 kilo ohm resistors, a perf board, perforated prototyping board, a capacitor 45 nanofarads, some solder. I have here some tweezers and a good old soldering iron. So first of all, what you're gonna do is you're gonna power on your soldering iron to the right temperature for your solder. And this is the circuit schematic, this is the MOSFET. So we're gonna do this later, driving an inductive load, and I'm gonna show you how to drive it. So this is the circuit. I'm not gonna be putting this capacitor right here. This is the filter capacitor in case you have a bad power supply or something, just a filter capacitor. I'm gonna put this nearby. You can take a picture of it, have it on your phone, but I'm gonna put it nearby so I can see it right here. Also, you're gonna need some wire. So first of all, I put the socket. As you're looking at the 555 timer, you have this notch right here. So this notch right here, this is 1, 2, 3, 4. So this side is 1, 2, 3, 4. And then 5, 6, 7, 8. Put this in the middle, sort of in the middle, just has to be symmetrical. Let's actually get it around here, right? What helps is some little helper hands. Not right now. Right now what you're gonna do is you're gonna put it like this down. And a fan really helps. I'm gonna be using a fan. So I have this 3D printed fan enclosure with a 12 volt fan, and I have the 12 volt wall adapter, and I just plug it in, turn it on, and it works. So yeah, right now you wanna have a clean working space, so put the fan right here and solder. So this is gonna be a half soldering tutorial. Turning this on, and you're gonna take your solder right here, clean your soldering iron. Now I recommend you get real close. I don't have really good eyesight, so I have to get close. What you do is you put your soldering iron, tinned, you heat it up, and then you put some solder on it. I really can't see the pins right now, so you tin your soldering iron, put it on the pin, and then solder it. Good. I just don't see anything. It's the same color as the pads. You will need to get close, which is why you have a fan, so it doesn't blow into your eyes. You can clean it up later. When turning off your soldering iron, you always tin it at the end. Tin it a bit, good. And now you have this beautiful little solder job. And now, what I recommend. So, you have these things. These are potentiometers, and the pins come damaged. What you do is you bend them straight with pliers. You just hold all of them at once, and now you can bend this straight. So that's good. And now this, I got my parts, everything off AliExpress. Good. So now we have this. In which orientation you wanna put the 555. This is the notch, so L1 is here, 8 is here. And now, following the schematic that I showed earlier, you connect 8 to 4. I'm gonna go grab some wire. So I have a wire cutter right here, and I have this length of wire right now. I have a clean workstation. I know your workstations are filthy, and not filthy in the sense that it's dirty. Filthy in the sense that you have a lot of projects going on. And trust me, I also have a lot of projects. I have these inductors, I have like this full bridge rectifier, I have 2 ZVS's on my table. You can keep it clean even if you have a lot of projects. You cut the very end and about how much you need. Sadly, you can't find really thin wire. That's like really hard to find. You could have like those DuPont wires, but those are rare because you have to buy breadboard kits. So 4 is right here. This is 8, 4 to 8, connecting 4 to 8. Turning my soldering iron back on and making another one for 2 and 6. So another wire for 2 and 6. Taking a bit off. Now if I wanna wrap it up and twist it, the wires, what I do is I hold the copper, and then I twist the wires like this. Once again, I hold the wire, I hold the copper, and I twist it. And now, you put your wire in this, both of them. You turn on your fan. If you don't have a fan, you can still do it. I used to do it a long time with no fan. And now you solder, you have it tinned, you put the solder on, and you just solder it. You don't want a lot of solder to get onto this. I have this little solder hand, good. Everything is soldered. Turning off the fan just so you can hear me properly. Soldering this thing. Now I turn my fan back on again and I check. I always check. So this is 4 and this is 8. So if I flip it, this is 4 and this is 8. Good. Diagonals anyway. This is not the method. This is the method. I like soldering on the mat itself. I don't need to have it elevated. And now this is where you use the tweezers, because it's gonna get hot. The wire is gonna get hot. The insulation is gonna get hot too. You heat it up. You wanna melt the solder that's on the wires. You wanna melt that 100%. You thin your wires some more. This is so bright, and I don't even have all the light. I need some more solder. If you need some more solder, do it. If you need flux, do it. You can clean it later with a toothbrush. So this looks nice. You could use thinner wires. If you use thinner wires, it would have been better. The solder here doesn't look that good, so I'm gonna redo it. You don't wanna skip for 10 seconds now. This took like 10 seconds. It's gonna take a whole lot more than 10 seconds diagnosing the issue. So we have 4 and 6, and now we need 2 and 6. So 2, 1, 2, 3, 4, 5, 6. So these two. This one is much shorter. Hold it with your tweezers. You can use a hot air gun, but I don't like them. I have a hot air gun. I don't think it's that powerful. It doesn't melt solder. Is this good? Visual inspection? No, it's not good. It needs a bit more solder. It's a cold joint. So again, tweezers, hold it right. Okay, good. And now you clean your tip. See how useful this is? It's not the most high-powered fan, but it's pretty good. Visual inspection. Okay, now you're gonna bend it and put it into, no, not that one, the other one. Don't try and flex it too hard like I'm doing here. I just don't have the right thin wire. The insulation is coming off. This happens sometimes. You just redo it. You bended the wire too much. Okay, so I removed that. The insulation was destroyed. I need way thinner wire. So this is pretty hard with thick wire. So once again, we're preparing the wire. If you had thinner wire, you could also cut off like the legs of your capacitor a bit. You could do many things. I'm gonna just try and do this the hard way, because if I do this the hard way, it proves you can do it the hard way too. So again, I have to tip it. I have to tip the wire. So 15%, around that. That's a pretty good margin. It gets stuck onto my tweezers because I got it hot. Now we have to check it once again. 1, 2. So this one, it's really visible because it's kind of broken. Soldering is really hard unless you're up close. Be careful when you're grabbing around. You can seriously melt your hand off. And by seriously, I don't mean, oh, I've hurt myself. I mean, stop soldering for a week. I mean, from soldering daily to not wanting to solder anymore. The worst I've gotten melted is when I put it like this on my hand, on that exact spot. I don't have a scar, luckily, but always inspect it visually. Always dock your soldering iron. Don't try and reach for stuff with your soldering iron in hand. So thin your soldering iron at the end. That's how you take care of it. And now, what's the next step? The next step is potentiometer. So all the potentiometers come and go to pin 7. So pin 7 is right here. From pin 7, I'm gonna draw 2 1-ohm resistors. Row of 1-ohm resistors, because they're common in every circuit. You have a MOSFET, 1-ohm resistor. You have a whatever else you have, 1-ohm resistor. I bet you every appliance in your house has a 1-ohm resistor sprinkled somewhere in there. And from here, from this point, we need 2 resistors. 7, both of them on 7. Both of the ends go into a potentiometer. So 1 potentiometer here and 1 potentiometer here, I guess. And you twist it like this. You keep it on the board and you twist it. I've twisted enough, probably, yeah, more than enough. We'll solder it later. Now let's go on to routing other components. First of all, why didn't I put my 555 chip in? This little 555 chip? Because it's gonna get hurt by heat and you want to like not kill it with heat preferably. 1 potentiometer goes here. If it's not straight enough, the legs aren't good, you bend them back with the pliers. This works as a pliers in a pinch. So yeah, still not straight, more plying action. Seems that this brand doesn't want to fit. You have to push it. Interesting. They're a bit too big for my soldering pans. That happens sometimes. Last ones I had have no problems, but sometimes you have to push them. If you really have to push them, just bend it with your pliers again. One of the times you don't want it to be 100% straight. Good thing is that they won't slip out because they're pushed in. So that's a good thing. And now soldering these. It's very simple. You do the exact same thing you did on the pins of the 555 timer IC, but on 3 pins instead of 8. I have my soldering iron right here. So again, clean, try and have a space for your hands, clean everything. Turning on the fan, don't melt yourself with the soldering iron. And now soldering. Tin your iron, put it on the pin, heat up the pin. The resistor is in the way. So that's the goal, you want to make it flow. It absolutely flows. If it's hot enough, it just flows. And later for the visual inspection, not enough solder, and that's gonna be a cold joint. That's a good joint. That's pretty good. That one has like a touch too much solder, you could say, but I don't think too much solder hurts as too little solder. Too little solder could destroy the circuit. You wanna have your iron tin and solder your resistor. You basically want to trap your resistor inside a net. And now on to cutting the resistor. Tin your iron, dock it, close the heat. I don't know why people say that closing on and off your iron is really bad. I don't have any problems with it. Now hard method is the pliers, easy method is nail clippers, and easier method is a special tool. But who has the special tool? I really don't see it except for in kits, and I don't want to buy a whole $40 kit for one tool. It's better to be conservative and bend it later than to not be conservative, cut too much and have to put a wire on. It's really embarrassing when you have to solder extra wires. Look at this little 5x5. I'm gonna reunite it with its 5x5 family. And yeah, so this is the 5x5 family and this is their home. I have the 5x5 family and the home. Well, that's really just the home for one, so let's put a home for two. Hey, let's add a voltage regulator into this. I don't have any voltage regulators, but I have the big brother and I have grandpa and grandma. So that's enough. That's enough with the jokes. We get to soldering. Tin the iron. I don't have that much experience in soldering. I'm not gonna claim to be soldering since I was 2. I'd say I'm pretty good at soldering. Visual inspection, nothing. Horrible. Okay, that's a good way. You can hold it down with your iron, but it's way too close to pin 8. Visual inspection again. After each solder job, you do a visual inspection. Good. I wish I had smaller wires. And now next step is looking at the schematic again. Another wire from the potentiometers to pin 2 and 6, and then you add a capacitor, timing capacitor. Pretty nice. Now we look what's next. So I put the potentiometers, I just have to drag out that wire. I got my wire prepped right here. This is the full resistance, this is 10 kilo ohms, and this is the variable resistance to pin 2 and 6, so to that one right here. That is enough. Now we clean our irons, we tin our irons, and we turn on our fans. Sorry if I smoked you a little bit. First of all, you gotta tin the wire. The wire can be tinned on the table, you can do it to the claw. I like tinning it to the table sometimes, depends on my mood. If you had like other circuits, you'd use the hands a lot more. The hands are very useful if you can do like good solder. They're useful for many things, but not for this one because you can lay it flat. If it's not flat, you didn't make the circuit flat, it can be horrible working on it, especially trying to solder on it. So I have to melt this one too. If you don't melt that one, it's almost useless. I accidentally melted my fan a bit. And now we need a bit more tin. I use non-leaded. I think non-leaded is a lot better in my opinion. You do you. If you've been using it since you started soldering, you do you. I think it just flows weird in my opinion. So visual inspection, that's good. I've soldered that. Pretty good. Throw all the scraps away. And now this, we put this capacitor right here and we solder it to ground. Pin 2, this goes to ground. I don't know where ground is. It's probably below me. I need to take the tin. This is a used capacitor. And what I'll do is I'll tin my iron. I'll tin it and then I'll remove everything. If you can't do this, if it's not working, you can use a lighter. But be careful to not torch your capacitor. If you torch this capacitor, it's bad. I don't know what to tell you. The capacitor is torched. Oh, I was jamming it into the wire. Yeah, don't do that. I have to go with the lighter. So I have one of these lighters. And now I can just put it in. Well, it's that thing. Well, it's that thing right there, so I'm gonna just torch it a bit. You torch it a bit so it flows all over the capacitor. And now this is ground, and that is connected to pin 2 and 6, as shown earlier on my schematic. Visual inspection, everything looks nice. And now another thing, if you ever suspect, you just pull on it. Now the next step is 4 and 8. These two should be connected together. Where is my wire? It appears the red wire is longer than the black wire, so I'll have to shorten it, and then they will be my positive, negative. And then after that I'll put a DC plug, and then after that I have a fully working 555 timer IC that you know how to fix in case something breaks. Because that's the reason you make these. You don't make it because it's better. It's the same thing as those PWM pins. You can buy them really cheap, like $2. You don't make those because they're better. They're arguably a bit worse because it's on capacitance. So arguably like a few percentage is worse. But you know how to fix it. You know what it is. You know how it works. You have more 555 timers IC. Is this all? No, we need positive and negative. Luckily, I have the positive and negative right here. It's called the positive and negative. Technically, I could power it right now, but I don't want to have a mess of alligator clips and break the wires. If you don't have solid connections, it's not gonna be solid. It's gonna be a bad day if you don't have solid connections. Like if you're making a prototype. That's when I use the alligator clips, when I'm making a prototype. I don't know why people always complain about alligator clips. That's their purpose, for prototypes. They're not supposed to be good. Most alligator clips you buy that are like pre-made, it has some iron in it. It has some magnetic material in it. Doesn't mean it's horrible, it has a ultra high resistance. Now we solder this. Now some more wire that I can steal. Where's some more wire that I can steal? So I can steal some wire from here. I have some wire on my wall. I just have the wire cords on my wall, don't worry. I'm not stealing wire from other projects. This is a bit too big. This is wall wire, so it's even thicker, but I don't want to take out more audio wire. This is way too long. I made it that way because I can bend it. For example, right now, I would have melted the 555 timer IC with the amount of heat I just applied. Like just now. And the amount of solder I'm applying now because I want a good connection on those. And now cleaning. I have metal brush with a 3D printed enclosure. This is the final product. Final inspection. Pin 5 is empty. Pin 3 is output, of course. I forgot output. I have some perfectly thin wire. Maybe I'm bad at soldering, I don't know, but I just need thin wire. And now really precise. Wait, what pin is that? So 1, 2, yeah, this is pin 3. Just making sure. If you have too much solder, you can stick to other pins. So if you see that there's a bit too much, remove it. Good. Cleaning my iron. And that's about it. That's the whole circuit complete. And now I'm gonna go grab my scope. And now we evict the family of switches. First of all, let me turn on my power supply, grab my power pins, put my scope into frame. Always 10x your scope. This is ground. I like to ground my ground. And then this is output. So let's see the output. Nothing is burning, that's good. I forgot to put the 555 timer IC in. Visual inspection of the 555 timer IC. Bend this capacitor to give yourself a bit more space. Good. Yeah.
Yeah.
Yo.
What I've been waiting for. That's what it's all
Look.
about. Woo.
And it's adjustable. Pretty cool, right? Just saw me build circuit from scratch. My scope is not that good with frequencies. I have to adjust it. 40 kilohertz. Perfect square wave. You know how to fix it. You know how to make more. You can print out copies. You can give them to your friends and families as gifts. You can do everything you want to them. Will your friends and family know how to power one? No. Is it a cool gift? No. Should you ever give it to someone? No. But it's cool. That's about it for today's video. So this is how a normal day of operation in the lab looks like. Me just soldering circuits. This is the final circuit overview. I guess you guys are rating my soldering. This is the final circuit and this is how it looks like. This is the soldering. Maybe it's horrible. Maybe you say it's horrible. Maybe you think it's nice. I wish I had thinner wire, but the thinner wire is harder to work with. So this is, I'd say, the hardest thing is putting the wires, but this is a pretty easy thing to do. Anyways, see you next time.